A very good morning, dear children. Today we are going to continue with the remaining part of Chapter 3, Chemical Reactions and Equations. So in the last class, we learned the method of balancing a chemical reaction. We also learned very important concepts about chemical reactions. Today, we will be learning about the different types of chemical reaction in which we will be learning about combination, decomposition, displacement, double displacement, and along with this, we will also learn about exothermic and endothermic reactions. So to begin with, let's start with combination reaction. Let's just try to understand combination reaction by this representation. The representation is A plus B gives AB. Now here, as you can see, we have already learned that in a chemical reaction, the left hand side represents reactants and the right hand side represents products. So when you're looking at the left hand side, we can clearly see that there are two reactants. A is the first reactant, B is the second reactant. So we have two reactants, but when you're looking at the right hand side, we have a single product and the product is AB. Okay, so when you're looking at any reaction, if you have two or more reactants which are combining together to give you one single product, that becomes combination reaction. Let us try to understand this by looking at several examples. The first example we have is that of the formation of ammonium chloride. So here what we have done is we have taken hydrochloric acid in a conical flask and we are heating it. Simultaneously, as it is heating, we will take a glass rod and we are going to dip it in the ammonia solution. And after that, we are going to hold it on top of the conical flask. When we hold it, we will observe that there is white smoke that moves out from the tip of the glass rod. What really happens here is because of the heating of hydrochloric acid, vapors start coming out from the conical flask and ammonia also comes out from the solution on the glass rod. So because of this, what happens is the vapor of ammonia is formed, the vapor of hydrochloric acid is formed, and both these gases, they react to form the salt ammonium chloride, which also is in the gaseous phase state first. But immediately, because of the condensation process that happens at the room temperature, it gets transformed into the solid state, and that is why a white smoke is being formed. So the chemical reaction here would be NH3, that is ammonia, plus HCl, that is hydrochloric acid, gives ammonium chloride, that is NH4Cl. So here also, if you look at the left and the right hand side, you will see you have two reactants on the left, that is ammonia and hydrochloric acid. And if you look at the right hand side, you have only one product, that is NH4Cl. So this is a first example of combination reaction. The second example we have is the burning of magnesium strip. When you burn magnesium strip, you will see that there's a white powder of magnesium oxide that is being formed. Initially, when you're holding the magnesium strip on fire itself, the fire has a very bright light, and then slowly as it completes its burning, there's a white powder which is released, and that white powder is magnesium oxide. So the reaction here is Mg plus O2, that is magnesium plus O2. O2 is nothing but the oxygen that is there in the air. Okay, so magnesium, that is the first strip that we're taking, that's the first reactant, plus oxygen, which is in the air, is the second reactant. So we have two reactants which are combining together to give rise to one single product, that is magnesium oxide. So this is a second example of combination reaction. The third reaction we are going to take is, we will be taking calcium oxide, which is also called as quicklime. We take it in a beaker, and in this beaker we are adding water. When you add water, this calcium oxide reacts with the water and forms calcium hydroxide, which is also called as slaked lime. Now, while this reaction is going on, if you actually touch the beaker, you will see that the beaker has turned hot. This is mainly because this reaction where calcium oxide is reacting with water, it is an exothermic reaction, or it is a reaction where a lot of heat is released out. That is why if you see in the reaction given below, on the left hand side you have the reactants written, that is CaO, calcium oxide, plus water, H2O. And on the right hand side you have only one single product formed, that is CaOH twice, which is calcium hydroxide. Because it is releasing heat, that is why on the right hand side we also mention plus heat. Even though plus heat is mentioned on the product side, it is not considered to be a product, and that is why even though two products or two substances are written on the right hand side, still you consider this to be a combination reaction, because heat is not considered as a product. You will consider only CaOH twice as a product, and you have two reactants, that is CaO plus H2O. So combination reaction can be defined as when two or more reactants combine in a reaction to form a single product. It is called as combination reaction. So here one thing you have to know it is that reactants can be two or even more reactants can be there. There may be some equations or some chemical reactions where there will be three reactants or four reactants. The number of reactants may change, but the product will also always be single. So that is what is combination reaction. Now going on to the next, that is decomposition reaction. Here we will look at the representation. Here I have AB gives A plus B. Now if you remember about combination and try to compare these two, you will understand decomposition reaction is completely opposite to combination reaction. In decomposition reaction, we have only one reactant, but that one reactant is decomposing, or it is breaking up to give two or more products. So let us learn this by taking examples. Here we have taken, in the first example, we have taken sugar in an evaporating dish and we are heating it with the help of a burner. Now, after some time, you will see that there's a formation of a burnt out black substance. This substance is formed because a single reactant, that is sugar, is getting decomposed, or it is undergoing the process of decomposition to give rise to two products, that is carbon and water. Carbon is a black colored substance. Here if you see, because I'm having only one reactant on the left and I'm having two products on the right, that is why this becomes a decomposition reaction. The second example we have is, we have taken calcium oxide in a test tube. We have to fit a bent tube to this test tube with the help of a rubber cork. Insert the other end of the bent tube in freshly prepared lime water. Heat this powdered calcium carbonate in the first test tube strongly. What basically happens is that calcium carbonate, it undergoes decomposition and carbon dioxide gas is formed. This carbon dioxide gas passes through the bent tube and enters into lime water. Once it enters into lime water, as you can see on the screen on the right hand side, the lime water is becoming milky. It is turning white in color. In this, you have two products formed. The reactant is only one, that is calcium carbonate, but on the right hand side, if you see, you have calcium oxide plus CO2. Now, here two products are there. Calcium oxide is in the first tube. It remains behind in the first tube only. Carbon dioxide passes through the bent tube in the second test tube, which contains lime water. Here, if you see, there is an arrow pointing upward in the reaction, as we've already learned that whenever you want to show that any gaseous substance is liberating from the test tube, you normally depict it with the help of an arrow upward. That is why carbon dioxide has an arrow upward. The next example we have is water's decomposition into hydrogen and oxygen when electric current is passed through acidulated water. We know that pure water is not a good conductor of electricity. That is why whenever water is taken for electrolysis, we add little amount of acid into it so that electric current can pass through it and the decomposition can take place. Here we have an anode and we have the cathode, and we have added water in this. Now what happens is, because this decomposition takes place, hydrogen moves towards the cathode and oxygen moves towards the anode, thereby bringing about the separation of the atoms which form this water. So as the reaction, you can see H2O, that is 2H2O, which is one single reactant, is giving rise to two products, that is H2 hydrogen and O2, that is oxygen. So we can define decomposition reaction by stating that when two or more products are formed from single reactant, it is called as decomposition reaction. This, as I already told you, this is the opposite of combination reaction. So the reactant should always be a single reactant, but products can be two products or even more than two products can be formed, but reactant will be single. Now going on to the next example, next type, that is displacement reaction. Let's look at the representation. Here AB plus C gives AC plus B. Now if you look at the left hand side and the right hand side, the number of reactants and the number of products are the same. But if you look at what is happening to the reactant, you will understand why this reaction is termed as displacement. C, which is a more reactive atom, is taking the place of B, which is a less reactive atom. So AB, when it's reacting with C, C is changing its place. That is why displacement. It's changing its place, or it's flipping its place with B, and B is released out. That is why this is called as displacement or single replacement. Let's look at examples. Here we are taking a strip of zinc and we are adding it in blue colored copper sulfate. After a few minutes, you will see that a colorless solution of zinc sulfate is formed and heat is generated. If you look at the chemical reaction, it is Zn plus CuSO4 gives ZnSO4 plus Cu. So we are clearly understanding from this that Zn, that is zinc, is taking the place of copper, that is Cu. Because this reaction is happening, we can easily identify that zinc is more reactive element, and that is why it is taking the place of copper, which is less reactive element. So we can say that displacement is the reaction when the place of a less reactive element is taken by more reactive element, and that is called as displacement reaction. Now coming to double displacement reaction. Let's look at the representation. AB plus CD gives AC plus BD. The number of reactants and the number of products are the same. The only thing that is happening is here, instead of one element taking the place, two elements are changing their places. That is why the word double displacement. Here, C is taking the place of B and B is taking the place of C. Because two elements are exchanging their places, that is why this is called as double displacement reaction. Here the example we have is, we are taking yellow potassium chromate and adding it into colorless solution of barium sulfate. It obviously goes to say that the product which will be formed will be barium chromate and potassium sulfate. That is, they will exchange their places. I'll repeat. Potassium chromate reacts with barium sulfate and the product will be potassium sulfate and barium chromate. The barium chromate which is formed is a yellow colored precipitate. So, double displacement can be defined as when components of both the reacting molecules are exchanged to form the products is called as double displacement. Here the word exchange is very important. Now, reactions when the reactions are happening, at that time many a times heat can be absorbed or it can be given away. According to the processes and the reactions, they can be classified as endothermic and exothermic reactions. If the reaction is giving away heat, it will be called exothermic. Exo means out. And endothermic will be those reactions where heat is absorbed or it's taken inside. That is why endo. In the process of dilution of concentrated sulfuric acid with water, very large amount of heat is liberated, and that is why if you add water in concentrated sulfuric acid, because the amount of heat is so high, the water which is added will get evaporated instantaneously, and that is why it may cause accidents. That is why what is done is, in water, little amount of concentrated sulfuric acid is added little by little and continuous stirring is done. Because you're doing it in this way, the amount of heat that is liberated is small at a time. So this process of dilution of sulfuric acid is an exothermic process. Why? Because heat is moving out from the solution. For understanding about exothermic and endothermic, we will do two experiments simultaneously. Here what I've done is I've taken potassium nitrate, that is KNO3, and I have also taken sodium hydroxide, that is NaOH. What do I do first is I will take two beakers. I will measure the temperatures first, and after I've measured the temperatures, I will add these two powders in the different tubes. After I've added these two powders in the water whose temperature has been measured, after I've allowed it to mix and dissolve, then again I will take the temperatures of the two water beakers in which the substance was added. I'll repeat again. I've taken potassium nitrate and I've taken sodium hydroxide. I have taken two beakers of water which the temperature has been measured, and in these two beakers in one I've added potassium nitrate and in the second one I've added sodium hydroxide. I allow it to mix properly, I allow it to dissolve properly, and after it has happened I will measure the temperature again. You will see during the process of the dissolution of potassium nitrate in water, heat from the surrounding is absorbed, and that is why the temperature of the resulting solution is less. The process in which heat is absorbed from the outside is called endothermic process. Similarly, in the reaction in which NaOH was dissolved in water, heat was given out and therefore the temperature rises. The process in which heat is given out is called exothermic reaction or exothermic processes. So how can we define exothermic reaction? When the reactants are transformed into products, if heat is given away, then it is called as a exothermic reaction. And endothermic can be defined as when reactants are transformed into products and if heat is absorbed from the environment, then it is called as endothermic reactions. So these are the reactions and the definitions of the reactions which have to be learned by all. So there are total of 6 of them. In the next class, we'll be learning about important processes of what determines or what are the factors which affect the rate of the chemical reaction. Along with that, we will also be learning about oxidation and reduction. I hope what was done today was clear. Thank you.